Welcome to a practical introduction to bypassing application whitelisting. This workshop was built specifically for GreyHatCon 2020. My name is Joe Leon. I am an offensive security engineer with 40 North Security. Previously, I've instructed at Black Hat, both Black Hat Asia this year as well as Black Hat USA last year. I've also taught at Wild West Hackin' Fest. I am an open source offensive security developer, so I've built the tools Excellent Donut, which is a XLM or XL 4.0 macro generation tool. I also built Sutu Concealer, which is a malleable profile generator for Cobalt Strike. Also have contributed to a couple other tools. Prior to cybersecurity, I was a full stack web developer. And then prior to that, I was also in sales for about 6 or 7 years. So by the end of this workshop, I just want to set context so you know what you're getting yourself into. These are the goals that I have for you. So first, you're going to leave here being able to describe what application whitelisting is and why it's used. You're going to be able to identify 4 specific Microsoft signed binaries that you can use to bypass some app whitelisting technologies. You're going to understand generally how app whitelisting bypasses can be used both for initial access as well as lateral movement. And finally, you're going to actually have some hands-on experience with some workshop exercises practically bypassing these security controls. And one thing I'll note before we jump in, if you know how to run an MS Build app whitelisting bypass or WYMIC, this course is going to cover those. And I recognize that there's a whole diverse set of experiences here and people with different skill sets. So if that's you and you have experience running these, a lot of this will be repeat. But I will say at the end, I've included some new stuff, which I try to do in all the talks that I do, specifically related to the F# scripting console that probably will be new to you. So if you want to stick with that, with us till then, that's great. If you want to jump ahead, that'd be fine too. And for those of you that maybe don't even have the slightest idea what app whitelisting is, that's totally cool too. We will cover the basics as well. So just kind of level setting there in terms of folks with different backgrounds. In terms of what you need for this workshop, really not that much. I imagine a good chunk of you are using a Windows host. As long as you can turn off Defender on your host just for the workshop for these exercises, that's totally fine. Ideally, though, you'd probably have a Windows VM. I imagine most of us have a Windows VM kind of available to us, so you could just use that, but please turn off Defender. And the reason I say turn off Defender, I know some people are like, well, like, is this like that practical and can I actually use this? I have to turn off Defender because targets don't. And the answer to that is this is a workshop designed to learn how to bypass app whitelisting, not to bypass AV. And so those are 2 different concepts. So ideally, you can take the proofs of concept for bypassing app whitelisting and combine that with some other knowledge or skills or workshops or whatnot about how to bypass AV, and you combine them together, and then you have a full-fledged option, tactical option for assessments or for labs generally. In addition to needing a Windows VM or host, there are course files. So if you go to github.com/40northsecurity/presentations, you will see a GreyHatCon 2020 folder. Inside that, there's a README that explains everything that's going on. There are links to the exercise demo videos. There are links to the files that you'll need to complete the exercises. You can download that, so you could clone it. You could just download it through GitHub, or you could even just copy paste specific files as you need them. Totally up to you. And this Dropbox link contains some files that you'll need for the last exercise related to the F# scripting console. That's a Dropbox link because those are Microsoft files. And this is more just for folks taking the workshop to use those files. But if you have Visual Studio installed, you can get at those files yourself. Like you already have those files. But this is in case you don't have Visual Studio installed. We're providing those files just for this workshop. And then that link is gonna go down in a couple of days, just so you know. All right, what's our roadmap here? So first, I want to explain to you guys what is app whitelisting. Just fundamentally, what does it do? How does it work? The general idea. We're going to cover a little bit about App Blocker and Device Guard, also known as WDAC, just because those are 2 common implementations of application whitelisting control. They're built in with various versions of Microsoft. I'm going to discuss briefly, if you're interested in creating your own app whitelisting lab, how to do so and point you to some resources. And then last, we'll cover 4 bypasses. And you can see in light gray there my opinions on some of those. All right, let's jump in. So what is application whitelisting? just broadly speaking. It is a rule set that says these applications, so these binaries, these executables, so these .exe, .dll, .msi, etc. type files, the ones that I'm saying are on this approved list can run. Anything not on that list cannot run. And I think this is a nice little graphical way to look at it. So we're saying here, all Microsoft signed, meaning Microsoft distributed and owned and produced, published, XCs, DLLs, etc., are allowed and are permitted to run. Also Slack, Chrome, and QuickBooks can run too. And that's it. Everything else is denied. So this is a very imagine this is like a pseudocode version of an actual policy. But I think that it clearly demonstrates the idea here. And so why does this technology exist? Why would we use it? So there's a few reasons. I would say at the base of it, the bottom line is that app whitelisting is used to control the applications that your run-of-the-mill employee is running inside of an enterprise network. That's the basic idea. As an IT administrator, you don't want your employees running all types of random software that they're just downloading from the internet. That opens you up to custom malware or even just commodity malware being run on a machine. And just generally IT wants to know what's going on in their network. So it's helpful to know only these approved listed applications are going to be run. So there's a bunch of different tech that deploys app whitelisting. So we're going to cover AppLocker and Device Guard, also known as Windows Defender Application Control, so WDAC. Carbon Black has app whitelisting tech. Quest does too, and there's many, many other implementations of it. But I would say in terms of when we're on pen tests or red teams, we commonly will see AppLocker or Device Guard. And so when we go into an environment on a red team assessment, we hope that they have app whitelisting enabled. And so we basically will default to using app whitelisting to move laterally or to gain initial access, often just because we will assume it's enabled, but many times it's not. And when we ask and have asked organizations and specifically system administrators or network administrators, why aren't they using app whitelisting? We typically get the answer, it's too much work or it's too hard. And fair enough, it is a pain in the butt to implement, but it's totally worth it. We've never recommended implementing an application whitelisting control to a client and then have later heard that they regret it. Never. This is an awesome, awesome technology from a defensive point of view to implement. And if you're on the offensive side of things, this is 100% something you should be recommending to all of your clients, at least in my opinion. So how is app whitelisting deployed? So typically it's configured by scanning a gold imaged system, so meaning some master system that is perfect. It contains all the binaries that you would expect to run and you want to run in your network. It's configured properly, it's scanned, and from there, a list of approved applications is built. But that's really tough to do. And it's tough because imagine, you're in IT and it's June and you're building this list of approved binaries. Well, it's June. We just got through tax season. You might not be considering one of the applications that the accounting team needs to use only in April, let's say. And for that reason, if you create this whitelist or approved list of binaries to run, and it's deployed and it's enforced, and then it comes around to next March, April, accounting goes to use the software, they're going to keep getting, oh, the software's been blocked. And that's kind of annoying. And that's just one case, but multiply that across all months, across all departments within a very large enterprise, and you can slowly see that this could be a challenge. The other element to this, and this is what we'll be discussing, is that an implication of scanning a gold imaged Windows system is that we are inherently trusting Microsoft signed binaries. And that's the whole idea here. We are going to bypass app whitelisting, we are going to repurpose Microsoft signed binaries to execute our code. That's the whole idea. Binaries that are already on the system, we're going to use, and that are allowed to run on the system, we're going to use to do something that they did not intend for them to do. And so on an app whitelisting protected system, even if this system is protected by app whitelisting, it's still trusting Microsoft code, it's still vulnerable. So this does not eliminate the threat of an attacker dropping this does eliminate the threat of an attacker dropping custom compiled malware, like it's not going to run because it's not on the list. But if we can repurpose an existing binary to execute our malicious code, well, then it's going to be vulnerable. And so many of you might be thinking like, oh, that sounds kind of familiar. It's kind of like living off the land. So the Lolboss project, if you haven't heard of it, awesome project. It has a whole long list of different Microsoft binaries that can be repurposed to execute some arbitrary or malicious code. So we definitely recommend checking out that project. And I would actually, when I'm thinking like in terms of the relationship between living off the land and app whitelisting, bypassing, I would say app whitelisting bypasses are kind of like a subset under the umbrella of living off the land. So broadly, how does like app whitelisting work? Like, let's get into a few specifics, obviously not too detailed, but let's at least cover the foundational ideas here. So let's talk about AppLocker. Back in Windows XP, there were these things called software restriction policies. And basically it allowed you to restrict certain software from running, obviously, as you can tell by the name. But the challenge was some smaller and even medium-sized enterprises weren't deploying these SRPs very often. And it was primarily due to problems with launching applications from shortcuts or because path rules were too easy to circumvent. Basically, like bottom line is these SRPs weren't super effective and they were very difficult to implement. And so that kind of, like the concept was great, but it was hard to use. And so that kind of spawned the idea of creating a software tool called AppLocker. And this was built into Win 7 machines and newer, and it's still built in. You can deploy this via group policy. So this is a app whitelisting solution, just to be clear. And it provides very fine-grained control over how you implement your policies. And when I say fine-grained control, I specifically mean it allows you to identify specific users or groups of users on particular hosts and say which binaries they can run. So that's like super fine-tuned, right? So you can say like user X versus user Y have different permissions. And that's kind of interesting that you can do something so like fine-grained controlling on a particular host. In terms of the rules, you can build rules off a few different concepts. And by rules, I'll show you in the next slide what I mean. But you can build a rule based off the publisher of a binary, based on the binary's hash. On Win 10 1903, a newer AppLocker lets you publish a rule based on the path from where the binary was launched. That's the basic idea. And so I know that's a little intangible. So let's look at some examples here. So this is from the NSA. This is on their GitHub under AppLocker guidance, that repository. And they have a AppLocker starter policy that you can check out. But let's look at a few examples. So within these policies, so it's just XML formatting, so kind of easy to read and easy for a computer to read as well. We have rule collections, and they can correspond to specific types of files. So up here at the top, in the top box, you see it says DLL. Down just above the bottom box, you can see another rule collection that says type exe, right? So that's top is for a DLL, the bottom are for executable files. In this case, enforcement mode is set to audit only. I will explain the difference between audit and enforcement mode in a little bit. We'll definitely come back to that. And then you can see that there are file rules. And specifically in the big box, it says file path rule. And the general idea is everyone is allowed to execute all DLLs located in the Windows folder. So that's like C Windows. But there are some exceptions. You can see exceptions make up the bulk inside that box. And it says any file, or rather any DLL in one of those paths is not allowed, right? So we're saying like all of C Windows is fine except these carve outs. And the reason these are carved out is a lot of these, if not all of these, are world or universal writable and readable. So oftentimes when we're operating on a red team assessment or even an internal pen test, we will store files, like upload files that we need to use or operate out of C Windows tasks, C Windows temp, C Windows System 32 tasks, etc. And so because those are commonly abused files or folders where anybody can write to them, obviously that needs to be an exception. Otherwise, you would allow basically any DLL to be able to be run. And down at the bottom, the last box is just to show you like what a publisher example would look like. So this is for Microsoft. And so let's talk a little bit about how AppLocker is working underneath the hood. If you don't know James Forshaw, he has this blog. That's his blog URL there. But he did a few posts back in 2019 on the internals of AppLocker. Gets super in the weeds. For me, it was too in the weeds. I am not that technical. He is an incredibly detailed author for this type of stuff. And he's done a lot of work and development work. So I recommend getting to know him if you don't know yet, but definitely check out his blog. And if you want to know specifically how AppLocker works under the hood, there's I think 4 or 5 part series on there, but that's a link to one of those blog posts. But generally, I'll sum up what he covered is that after a process is created, but before the first thread is inserted, and that's key, right? So we haven't actually kicked off execution because you need a thread to execute. AppLocker is hooking into the process and is looking for rule violations. And if it sees a rule violation, then it's going to immediately terminate that process. So that's like the general, like super 30,000 high level feet view of how AppLocker works. And in terms of the files that it can block, we mentioned exes and DLLs, but there's a few other types of files as well. Limitations of AppLocker. The 2 biggest ideas here is that 3. If you have local administrative rights in the system, it's trivial to bypass any AppLocker restrictions. And there's many different ways to do that. Second, AppLocker only lives in user land, so it can't inspect down into the kernel. And then last, you are only as good as your rule set. I showed you some sample rules from the NSA's GitHub repository. Maybe an enterprise starts with that and then they customize it. Maybe they don't customize it. Maybe they forget to turn on enforcement mode, which I'll explain again in a few slides. You're really only as good as your rules. And to drive home that point, this is from Microsoft's MSDN, like the documentation on Microsoft's site. Like the default example rule for AppLocker is to allow local admins to run all executable files. And maybe that's needed and maybe that's okay. But to me, that kind of seems kind of crazy. Like, isn't the point to restrict access to executables? And one of the first things that we try to do when we get on a box, aside from establishing persistence, is trying to elevate our privileges to be a local admin. And if we do that, we can run any custom malware. That doesn't seem like a good idea. Not to mention, sometimes enterprises haven't locked down their hosts well enough, and regular users, operate as local admins. And then when we fish in, we already have local admin rights, and then we could run everything, thus rendering AppLocker ineffective. Device Guard. So Device Guard is also called Windows Defender Application Control. I believe that's the formal name, but you also see it as Device Guard. And we like to think of it as like AppLocker 2.0. It's available on Win 10 systems and Server 2016 and newer. So it's not going to be compatible with Win 7 and the corresponding servers. Another difference is that Device Guard applies rule sets to the entire computer. So not just like particular users on a host like AppLocker could. Deployed via GPO, so group policy object. And in this case, the rule sets are called code integrity policies. And I'll cover an example of that in the next couple slides. But improvements over AppLocker, because this is the newer technology. The biggest one I would say is it can look into the kernel, so below user land. So that's important. And second, while you might not have as fine-grained control over who policies apply to, you have more ways to build policies. And a good example is looking at process ancestry. So you can define policies by process spawning. So Microsoft provides us with some example Device Guard or WDAC policies, code integrity policies. You can find them in the folders where it's listed there. So C, Windows, schemas, code integrity, example policies. And I'll show you an example of one of these. This is the allow Microsoft file. So they start out as XML files. They're then compiled into a binary version. But that specific process is not super relevant right now, but I just kind of wanted to show you what one of the XML versions look like. And this one specifically built by Microsoft for only allowing Microsoft products to run. Okay, so I mentioned before audit mode, and you saw that on the NSA's example policy. So audit mode means we are running this code integrity policy or this rule set to theoretically block any unapproved binaries, but we're not actually going to block any. Instead, what we're going to do is if a binary would have been blocked or some file would have been blocked by this code set, this rule set, there will be a Windows event log event generated, but it will not be blocked. You might be wondering, like, why would you do that? Well, when you're building out a policy, if you think you have a gold image system scanned perfectly, you know exactly all of the binaries that you want to run, that's great. Run it in audit mode first, because I can almost guarantee you're going to see a few binaries here and there used by different users across the enterprise that you might not expect. And instead of having them get upset that their software that they use, say, every day is being blocked, it will generate an event for you, and then you can kind of investigate to see if it should go on the list. If you're on the defensive side generally, and you can't get buy-in for for deploying device guard across your network, at least build this code integrity policy so those event log events are generated, so that you can see and have a bit more telemetry in your environment to understand what software outside of what you expected is being executed across the network. And then enforcement mode is the mode where it's going to actively block any applications or binaries, etc., scripts that are run that are not on the approved list. So audit mode, enforcement mode, those are kind of like on and off switches. Now, if you're wondering, like, is Device Guard better than AppLocker? When I use which one? I'm not an expert in this, but broadly, here are some ideas. Device Guard, if you're in an all Win 10 environment, like, I would go with that. Device Guard it's a bit stronger of a tool for security reasons, primarily because it's less trivial to just shut off. It can hook into the kernel, and it can you can write rule sets based on things like process ancestry and other ideas that are a bit more advanced than just AppLocker's setup. But that said, AppLocker is great in mixed OS environments, so meaning like maybe you have Win 7, maybe Win 8, Win 10 machines, and it's also possible to block them, or to combine them. So a lot of organizations will combine the two. Okay, so that was like quickly high-level introduction. What is app whitelisting? Intro to AppLocker, intro to Device Guard. So hopefully for those of you that were not familiar with those technologies or app whitelisting generally, hopefully you have like at least a foundational understanding of what those are. So let's talk briefly about creating a lab. Again, a lab is not being provided to you for this workshop. I don't think it's needed, but I want to make sure that you are able to create your own lab to test this out. So to create a lab, I recommend having typically like a domain controller is helpful, so you can deploy this stuff via group policy, as well as at least one patched Win 10 Enterprise, I believe, or Education Edition virtual machines. I believe both of those allow Device Guard to be run on them. If you're just testing out these ideas, I would turn off Defender or whatever other AV that you have. In terms of AppLocker, if you want to deploy that, there's a link to that starter policy set from the NSA, as well as a lab setup guide below. And for Device Guard, there is a rule set there that has a code integrity policy. There's just like the default Windows one that's going to be built in on the machine, like that Win 10 Enterprise machine that'll just be living there, as well as an article that we wrote at 40 North about how to set one up. So those are some resources for you. This is how you can check if Device Guard is running. So there's like a PowerShell commandlet that you could run, and 2 means it's being enforced. And so, like, why would you create a lab? So number one, or just like thinking broadly, like when we go into an environment, we try to know what defensive technologies and controls are in place, and then we'll try to create a lab, just like even if just one machine, that's fine, that mimics that environment so we can test some of our payloads. Obviously turning off cloud submissions, but just to see if like what we're operating with can get by whatever antivirus or EDR is running. Same sort of deal with application whitelisting. So all app whitelisting isn't created equally, but even more importantly, rule sets are not, created equally. And for that reason, it's important to kind of have a little lab to test things out. And so that said, I would recommend creating a lab when you have a chance to do so. All right, I'm gonna take a sip of water, and then we're gonna dive into the details here of actual bypasses. All right, so we're going to cover 4 different binaries. Within like MS Build, for example, there's multiple variations. Within WMIC, we have a couple examples, and like the F# scripting console or interface should be brand new, I would imagine, to most of you. So register server 32. I will preface this by saying I never use this. But I want to start here because as it's written, this was probably the first one that everybody learned about when app whitelisting bypasses was created as a research discipline. And it really demonstrated how effective honestly how easy it is to bypass app whitelisting controls. And so Casey Smith, you'll see we'll refer to him quite a bit. So he's at Subtee. He's done a lot of research into this. Matt Graber has done a lot of research into this. And broadly, if you look at the Lowboss project, you can see there's been a lot of different researchers that have contributed to it. And so I try to reference them as I see needed here in the presentation. But please know that like the vast majority of all this work was done by others. I'm just here to try to bring it together to you in an easy to learn fashion. But we really stand on the shoulders of like folks like Casey Smith when it comes to this. So Casey discovered that there's this register server binary that can be repurposed. But before I explain how it can be repurposed for bypassing app whitelisting controls, let me explain like, what is this even? Like this is like a bunch of random letters.exe. So like, what does it do? First, you should know it's like installed in all Windows systems. It's located in the System32 subfolder under C Windows. It stands for Register Server, and the basic idea is it's used to register and unregister DLLs and ActiveX controls. It also can be used during registering and unregistering COM scriptlet files. And COM scriptlet files, I'll show you what an example of that is in a second, but that is what we're going to use to abuse this binary to execute whatever code we want. And so the general command that is of interest to us with Register Server 32 is listed there. S just stands for run silently, U for unregistered DLL, N for don't want to call this DLL register server function, and then I, and it should be a lowercase I under the command bullet there. That means we want to call the DLL uninstall method with the optional scriptlet. And this scriptlet is where our malicious code will live. And then the DLL name is a DLL that we want to register or unregister. The specifics here, this is more as a reference. Like don't get caught up in understanding all the details, unless you want to, of course, but it's not super needed. This is the key here. So in order to bypass some app whitelisting solutions, again, all of what I'm saying won't bypass absolutely everything, and different rule sets will block certain things. AV will even block some things. AV is probably going to block this 9 times out of 10. But the point is to learn a variety of bypasses so that you guys have a broad tool set or toolkit, and then you can draw from that as needed in different environments. So specifically to use this, the command's identical from before, but this time we have a specific COM scriptlet that we're referencing that is going to contain malicious JScript. JScript is Microsoft's version of JavaScript. That's a very crude way to explain it, but broadly you can think of JScript kind of like JavaScript, but it's not exactly the same thing. I'm not an expert on the differences either, so I'm not going to go any further on that. But if you're curious, you can look up JScript versus JavaScript on Google and see what it says. And then scrobj.dll is Microsoft script component runtime, and that's required when running this bypass. So you can't just put any DLL there, although you could copy that and rename that DLL if you wanted. But that's the basic command. I'll also note that you could host your malicious COM scriptlet remotely, and that's an example of doing so. So I keep saying COM scriptlet, what does that mean? This is what it means. This is what it looks like. So it's XML format. This is the POC by Subtee, and here's what it looks like. And so this is super basic. This is just JScript popping calc. That's all it's doing. And in fact, all the demos discussing today are just going to be popping calc, but if you take this a step further, you can write JScript to do whatever you want. And we'll get into .NET to JScript and Gadget to JScript, which allows you to take any arbitrary C# code, turn it into JScript, and then throw it into a bypass like this. But if none of those words made sense, don't worry, I will explain that when we talk about WMIC, which is WMIC. That's WMIC. So there's an example of popping calc. You can also do the same thing with PowerShell, so it doesn't have to just be command prompt. But that's the basic idea here. Okay, so I promised some hands-on exercises. Here's the first one. And so something I'll mention about these exercises. So you guys should have the files to them. Broadly, I give you steps on how to do it. It's not going to be perfect on everybody's setup. For example, If you're running this from a different folder, the /i calc.txt, you might need to pass in an absolute path to that. Each environment will be slightly different, but generally, I'm going to give you the steps of what you need to do. This one should be, or is, the easiest one. After giving you time to work on it, I'm then going to walk through a demo of every exercise. And those demo videos are available on a private Vimeo channel that you guys can view afterward. And those links are located in the GreyHatCon 2020 subfolders readme.md file. So you'll have access to all of those. So in case it's not clear for whatever reason, the demo video, or you want to see it again, you can watch that as many times as you want. And the GreyHatCon organizers mentioned that I shouldn't wait like 10 minutes for you guys to work on this. I'm just going to take like a brief pause, and then we'll pick back up. So you guys could, I'm assuming the way this will work is you can pause the video. I'm not entirely sure, but I was told to not leave too much time in between like when exercises start and when I give the demo. So that said, if you are working on this exercise, please hit pause now, or whatever it may be. I'm not entirely sure again. And then I'll pick up with the demo in just a few seconds. Okay, so this is going to be a demo for exercise number 1. So hopefully everybody can see this video. This is built into the slides, so hopefully it's clear enough. Again, if it's not, don't worry, please. You can view this on demand on a Vimeo private link. Okay, there we go. Okay, it's cool, it started. So here, I'll just say this is the exact same COM scriptlet file that you saw before. So nothing new there. It's labeled, or it's saved as calc.txt in the GreyHatCon 2020 subfolder. So this is super simple. All we're going to do, and there you can see calc.txt, we're going to call the register server 32 binary, which I don't even think requires a full path. I think you just type in reg server 32.exe /s/n/u/i. I gets the COM scriptlet file name and then scrobj.dll, and there it pops up. Again, I know popping calc is kind of like boring, but like there's a reason everybody does it, because, well, sometimes setting up like C2 infrastructure to demonstrate this can take extra time. But more importantly, a lot of this should be left up to folks like yourself, like watching this, where you guys should take the initiative to start thinking through like, what payloads can I use? How can I bypass antivirus or EDR detection, etc. And again, that's a whole nother class and course and a topic. Like bypassing AV and EDR is constantly changing and updating. So that's a whole nother field of study that's equally as interesting, but a bit different from the scope here. So that was the first demo. Hopefully that process worked out well. Hopefully you guys could pause and then restart. Again, I'm not entirely sure how that works, but hopefully that worked out for you. Limitations of register server 32. So to be honest, I'm not using it. The reason is AV's blocking this most of the time. And it's just super well known. This was discovered like several years ago. But that said, if you're interested in using it and you want to use it, TrustedSec has done, I stumbled upon this article they did. They did some cool research on how to bypass AV when using this bypass. So go ahead and feel free to check it out. And this example down here, automation server can't create object. I believe whatever system I was on was blocking the ActiveX object creation, which was in that JScript. And so that's why it wasn't working for me, but all types of reasons that this could be blocked. But bottom line is, I am not using this on any assessments that I do, red team or internal pen test or otherwise. But again, this was like the first one. I think it's a good place to start and to start learning. Okay, MS Build. This is the opposite end of the spectrum. I use this on 9 out of 10 assessments. Love MS Build. And what's cool is there are multiple flavors of MS Build. So there's inline tasks, which if you're one of the participants in this workshop that have used MS Build before, I can almost guarantee you used it with the inline tasks version, but you might not know about the custom tasks version. Again, all this research was done by Subtee, Casey Smith, so all credit goes to him. We don't want to take any of the credit for this. Again, this is just me sharing the knowledge that Casey Smith and others have found by themselves. So what is MS Build? Same sort of process, and this is going to flow for all of the bypasses. I'm going to explain a little bit about what the original intent of the binary was, what it's used for, and then how we misuse it for our own purposes. So MS Build was included with .NET version 2 and above. So most installs of Windows you should be able to find MS Build there. So under C Windows Microsoft.NET Framework v4 MS Build, so it should live there. It stands for the Microsoft Build Engine. And now what does MS Build do? Well, it's primarily used to build projects like code, like C# project files, for example. It's invoked transparently in the background by Visual Studio to load and build managed projects. So if you were to download like a .NET project, like, I don't know, like any of those Sharp tools, like Sharp DP-API or Sharp Chrome, Sharp Cats, or whatever the tool is with the Sharp name in front of it, and compile your own version in Visual Studio. Visual Studio is kicking off the execution of MS Build in the background when you build that project. So I can almost guarantee most of you guys have used MS Build you might not have even known that you used it before. So MS Build works so if you're using this on the command line, so forget about the Visual Studio invocation in the background. If you're going to call MS Build directly in the command line, you're typically passing a .project, .C# project, or .xml file. And those files will contain all of the steps that are needed to build the project, right? So each project has different requirements when you build it, and I'll explain that in a second. But broadly, that's the general idea here. And this is like a super basic example XML file that you could pass to MS Build. And that's specifically wanting to compile, like it would require another file called helloworld.cs living in that directory. And all you're doing is like compiling and then building that project. So super simple example right there. And so what we're going to do is we're going to misuse these XML files or C# project files. So again, it looked just like this XML, and we're going to include our own arbitrary C# code in there. And if you have no familiarity or experience with C#, please don't worry. I know diving into another programming language at first can be a bit daunting, but I'm almost positive all of you have some fluency or experience with some programming language, be it Python or JavaScript or whatever. So don't let that get in the way. Like, you can understand what's going on here. So this is how we'll use it. We'll call the MS Build binary and then pass in an XML or C# project file that will contain our malicious code. And so what does our malicious code look like? So this is an example. Again, this is a proof of concept by Subt. So this is the inline tasks version of MS Build. And I'll explain the difference between custom tasks and inline tasks later, but for now, suffice to say, this is like the flavor of MS Build we're looking at now. And so you see the same like basic idea, the XML file structure, and a few things to cue in on. So right above that first box, it says target and then class example, there's a tag there. And so that's relevant for us here. That's the name of the task that we're going to be called. And so task you can think of as like during the build process, like as we're compiling and building a project, we might want to execute some certain tasks during that build process. So a good example would be like if you need to set up a message queue or some type of counter that is associated with your application, like that can be set up by a task kind of like right before your application is built so that you have that running like already available to the application. I think that's like just broadly kind of like the idea with tasks. You can use tasks for any number of things, but in this case, we're going to have a malicious task. And so this class example task refers to, you can see it says class example a couple times, and that's on purpose. In the first box, using task name is class example. And then if you go down to the third box, it says public class example. So there's a reason those are all the same. And that's referring to that named task. And then we have C# code in that second box. So we're saying the CS stands for C#, and that's like the type of code we're including. The C data business is just to say like, don't escape like some of the brackets and different things because this is actual code and we need to interpret it as code. I don't want you to escape any of those characters. The third box, again, is the class example, and it's specifically a type of task, iTask, which comes from the Microsoft Build reference assembly. And then critically at the bottom, we are overriding the execute function, and that's where we can put in whatever malicious code we want. And in this case, you could see this is going to be a template for incorporating your own shellcode to do whatever you want for shellcode injection. And so everything else is either related to prepping for shellcode injection or comments at the top. So really just what's in the boxes are most important. So hopefully that walkthrough made sense. And so this is literally what we use on red team assessments. So we have this as an XML file. We call it MS-build and pass in the path to this XML file, which could be hosted remotely, by the way. And it will execute whatever in the code tag, within that code tag. And in this case, it's a process injection. So pretty handy. But your code is kind of out in plain view. What if you don't want your code to be in plain view? Well, there are ways to separate your C# source code from that file, which is kind of cool. And this might be something that if you've used MS-build before, maybe you didn't know. In this case, same sort of idea here. Actually, I'll go back for a second. In the code box, so box number 2 from the top, it says type equals class. In this example, we have type equals fragment. And we have an additional attribute that passes in the absolute path to a C# file. And so that's kind of cool. So we can separate our actual C# code from the XML file that we pass to MS-build. And so why would you do this? Well, sometimes for operational security reasons, you might want to separate your malicious code from a more benign looking document. So just an option for you to use. And that brings us to our second exercise. So please test out MS-build with the inline.xml file. You won't really need to make any customizations. If you want to try, not instead of pop calc, popping notepad or something, feel free. You can try process injection if you know how to do that. A lot of options, but I'll give you the base proof of concept there. And that's generally the command that you need to run. So with that, I will pause for 10 seconds, get a drink of water, and then I'll resume. But again, if you want to try this exercise, please pause or whatever it is you need to do to try that out. All right, welcome back. Excuse me. So this will be a demo for that second exercise. Let's play this video. So here we have that same proof of concept template that I was showing you before, but with a slight variation. In this case, we have a little bit of, well, you see this class example business in the task task, and we're overriding the execute function. But we also have this run PS command function defined, and that is some work based on Jared Atkinson and Justin Warner, who have created this little ability to kick up a PowerShell run space where you can asynchronously run PowerShell commands. So this is just some more code for you to check out. And the basic idea is, again, we're just popping calc, so nothing super fancy. And here we're calling MS-build, so that's where it's located on this machine, and inline.xml is what we're calling. So take a little bit to compile, and then calc pops up. And importantly, there's this build succeeded. So whenever I see green there, I'm always pretty excited because that means that it probably worked, or at least there were no errors. So that's important. Another cool thing about MS-build. So when MS-build is not provided an argument on the command line, so the binary is called alone. So it's literally just calling the MS-build binary. It's going to, by default, look for a C# project file in the current working directory. And if there's only one of those files in the current working directory, it will execute whatever's in that file. And so we could take our malicious XML file that we just created, rename it to a .C# project extension. You don't have to change anything in the file, just the file extension. And then you can, as long as you're executing MS-build from within the directory where this C# project file lives, there will be no command line arguments provided. And I think that's super cool. And now why is that important? Well, a lot of defenders can very easily audit command line arguments. And when all we're providing them is just MS-build, they have much less to go off of. So that's a pretty cool way to get around some defenses. So instead of making this an exercise, of course, you're welcome to do it. But I thought I would give a quick demo here. So let's run this. We're taking that inline XML file and just copying it to the desktop in this case. So I'm going to rename it by using the move command. So it's going to be renamed to inline.c# project. You can see it lives in there, and there's no other C# project files in there. We're going to call MS Build. So under C Windows, Microsoft.NET Framework v4 dot whole bunch of numbers, msbuild.exe, and then call just that. That's all you have to call. And there it is, build succeeded, and there's calc. So it was the same payload, so that shouldn't look anything new. But how cool is that? Like, there's no command line argument. So if you're using MS Build on an assessment, like, I recommend trying to use it like that, because I think that's pretty sweet. Okay, so that was inline tasks. And when I say inline tasks, I mean this. Like, I highlighted it in this image, but you can see like it's like literally inline in the XML file. And so that's like what inline tasks will refer to. But there's another way to do things, and it's called custom tasks. Slightly more involved, will not bypass device guard because we have to compile a DLL and we have to execute that DLL, and device guard blocks that. But app blocker, depending on how it's configured, could miss this, as well as other defensive technologies, other app whitelisting technologies may or may not catch this. So like while this does not work on device guard, I still think it's cool to know. And so there's 3 steps. The first is you need to write some C# code that defines a task to execute, and we provide that to you, so don't worry about having to write that. Then we're going to compile that into a DLL. I'll provide the command for that, so don't worry about if you haven't compiled C# code into a DLL, so that's not a big deal, so don't worry about that. And then we're going to create an XML file that will reference that DLL. And it does so through this like idea of a custom task. And so this requires 2 files dropped to disk, a DLL and an XML file. So that's like less ideal, right? But on the other hand, this concept of inline tasks is used a ton by offensive security folks and by real threat actors. And so it's kind of nice to have an alternative if you still want to use MS Build, because it's quite easy, but use a slightly different method. So that's the idea for sharing this. And again, this was discovered by Subti. So he's done awesome work. And this was something else that we picked up on from his research. So here is an example of the C# code on the left. So again, the same sort of deal. We need to create a task class. We need to override the execute function. But something that's interesting here is that we have this concept of the this.whatever. If you look at the third box on the left-hand side, it says this.myProperty. So in our XML file, we can create a tag with the name of the class in our C# code. So you see it says simple task in the XML file. It also says simple task in the C# code. That has to be the same. And then you can create an attribute. And in this case, the attribute is called myProperty, and that could contain anything that you want it to be. Now in our C# code, we can refer to that attribute's value by referencing this.myProperty or this.whatever the attribute is named. And so you could imagine having C# code that maybe it's a process injection template, but you don't necessarily even need to include your shellcode in there. You could have base64 encoded shellcode or whatever type of shellcode you have in the XML file. And so if a defender only gets a hold of one of these files, it looks a little more benign because there's no actual payload in the C# code, and there's no actual process injection runner in the XML file. There's no C# code in the XML file, period. And that's kind of cool. And then the other bit that you have to take note of in the XML file is the using task business. You're declaring this custom task with the task name simple task, so that corresponds to the class name in the C# code. And then the assembly file is referencing a specific file. And that file is called calc.dll in this example, simply because let's say the code was called calc.cs in the C# code bit to the left. Well, if we compile that, which I'll give you the command to do so in a second, by default, calc.cs will compile to, in a DLL, to calc.dll. And that's the reason it's called calc.dll, but that assembly file could be named anything.dll. And so those are just like proof of concept ideas there. And now we're at exercise 3. So this is going to be an opportunity for you guys to implement this. There is a file called calc.cs in the presentation files. That's pre-built to look exactly like what you see on the left-hand side. So all of the appropriate reference assemblies are included, etc. And then to compile that file into a DLL, there's a command you could use. So basically we're using the CSC binary. We're turning it into a target library. So that's just means .dll. And then there are a few reference assemblies that we need to include that wouldn't be included by default and would cause errors if you don't include them. So those are mostly MS Build related DLLs. And then once you're ready, you can call the MS Build binary against the custom.xml file, which will reference a calc.dll binary in that exact same directory. So give that a shot. Again, I'm going to pause for 10 seconds, and then I will do a demo of this exercise. Okay, this is a demo for exercise number 3. Excuse me. All right, so up on the left, we see our calc.cs file. We're defining a class of simple task. We are overriding the execute function. We are starting calc. We have this.myPropertyBusiness, so you can see what that looks like. And then this at the bottom for getting and setting that value. We're going to compile that calc.cs file. That is the same command that you saw in the previous slide or two. So we execute that. That creates a file called calc.dll that you can see there. Next, we're going to inspect our custom.xml file just so you can see what's going on. So we have this simple task created. My property, that attribute has a value of example of a variable passed into blah, 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 that string. And then we're defining a task, a custom task with the name simple task, and referencing this assembly file calc.dll, which was just created. And again, you can see in the calc.cs file, there's simple task and this.myProperty. Okay, so now we're going to run MS Build against that custom.xml file. And sure enough, calc popped up. And, oh, yeah, this is key here. So it printed out that value that we put in the this.myProperty area, printed that string out. And so like that's just an explanation of like you can see it actually passed in that value because I have console.writeLines. That's like a print statement, this.myProperty. So that's MS Build. I think it's pretty awesome. And I also wanted to share a little bit about how we use it. So we can use it to move laterally, but you could also use it potentially on an initial access vector, meaning like in a phishing campaign. So I've done some research into Excel 4.0 macros. I built a tool that generates them. And I just kind of wanted to share since I like that subject. And if you're not familiar with it, I just wanted to briefly introduce you to it because it's kind of cool. But I can show you how we can use Excel 4.0 macros to run an MS Build bypass. And so, yeah, you can read the options down there. You could dynamically write this, or you could reference a remotely hosted XML file, which is what we'll do in the demo. So XLM macros. If you haven't heard of this before, you might be thinking I'm missaying XML. That's not true. They are called XLM. It is not VBA, which is Visual Basic for Applications or something like that. XLM predates VBA, created in 1992. And when you insert a sheet into Excel, I'm sure you've seen this insert pop up many times, but you might not have noticed MS Excel 4.0 macro, and that's an option, and that's what we're dealing with. And when you create one of those sheets, you can do something as simple as equals execute, and then pass in something that you want to send to the command prompt. And in this case, it could just be, pop calc. So that's pretty cool. Full credit to Outflank because they've done like all the foundational research on Excel 4.0 macros. So if you're curious about these, please start with this article. Actually, this was like the first one that like reintroduced Excel 4.0 macros to the offensive security community. All right, so I'm going to just do a quick demo here of MS Build plus XLM macros. And this will also be a demo of seeing MS Build referencing a remotely hosted payload. So here you can see I've got this WebDAV server set up. So this is on a specific IP address in a WebDAV folder, and you can see there's a bunch of files in here. So I've just hosted these myself on an IP address that I control. There's an XML file in here, nothing fancy. You've seen all of this. This is going back to the inline tasks method where we are overriding the execute function and popping calc. So you guys have seen this already, nothing new. But this is a remotely hosted payload. And so just to show you it working first, we're just going to call MS Build referencing that remotely hosted payload. So give it 1 second to spin that up. And so it can't be a regular HTTP server. It has to be a WebDAV server, which you can create using Apache if you want. Recommend, if you don't know what a WebDAV server is and you want to learn more about how to spin one up, please just Google WebDAV, WEBDAV, and then Black Hills Information Security. They've got an awesome article from I believe 2017 that will walk you through how to do it on Apache. That's what I use when I need to set it up. And you can see there's two like backslashes to kick off, knowing that it's like a UNC path for the WebDAV server. And this is taking a while simply because it's remotely hosted and has to grab that file. But here you can see it popped calc using that remotely hosted payload. So we're going to go ahead and just copy that command. I'm going to open up Excel. And this is done in real time, so it might be a little slow, but hopefully not. We're going to right click to insert a new sheet. It's going to be an Excel 4.0 macro sheet. We're going to type in equals exec, and in quotes, we're going to just paste in that same command. And then after that, we're going to write equals halt, which will stop the macro execution. So that's just literally executing that macro. The way this works to make this auto open is renaming the cell A1 or wherever your macro starts to auto open, auto_open, and then it will halt when it gets to the halt bit. We can hide that if we want. We can make this like super fancy, like this is definitely totally legit, not phishing workbook, like please enable content and enable macros. So we can save that. So it's saved as test.xlss, or XLS rather. We save that to the desktop. I'll close that, and then I'll pretend I just received it in a phishing email. I reopen it. I hit enable content, because why not? And then it doesn't look like anything's happening, but in the background what's happening is MS Build is being run. It's checking in with that WebDAV server to grab that, that file, and then it's going to execute that build process, and then calc should pop up in a second here. And unless the video changed from when I recorded it, it should just be in a couple seconds. And there it is. So that's kind of cool. So that's like a vector to use one of these bypasses in an initial access setting. You can also do the same with VBA. Similar things, you can put MS Build in there. Here's a resource to try that out if you'd like, malicious macro MS Build by InfoSec Ninja. And I've used this before in an assessment. So just something to consider if you'd like. In terms of limitations to using MS Build, there's not really too many. Like, it allows us to execute arbitrary C# code without any command line arguments, which is pretty awesome. But do note that if you are compiling a custom DLL, because by default device guard isn't going to let that run, if it's in enforcement mode, then that custom tasks method might not work for you, but it could work on other products and generally in other environments. Okay, WMIC, so WMIC, WMIC. This stands for Windows Management Instrumentation Command Line. So WMI is Windows Management Instrumentation, and the basic idea there is it's like you can query via WMI to gather information locally or remotely, assuming you have admin rights on the remote system, information about that host. So things like process listing, like what OS is it running, patch levels, etc. And so WMI is used a lot by sysadmins. It's like definitely a common thing to see WMI queries shooting across the network. So that's not out of the ordinary. But as you can imagine, we are going to repurpose WMIC for something malicious. I will note there are x86 and x64 versions of Wimic installed, so please just keep that in mind as well. Okay, so Wimic, just using it normally, you could type in Wimic process get, and you'd get out some command line like stuff like this. Like this is just junk. Like it's not junk, it's a process listing, but like it's hard to make sense of it because it's formatted really weirdly. And so there's this format flag that we can pass in list, and that cleans it up quite a bit. So now it's a lot more readable. And so what we're going to abuse is the format flag. So once again, Subt, obviously we revere him because he's done a ton of research here. So we've referencing a lot of his research. But once again, Subt discovered that format flag can take in an XSL file, and these XSL files are kind of like CSS for XML. So CSS being the styling that makes HTML look good in your browser. XSL does the same thing for XML. And so we can put some arbitrary code in these XSL files. And so this is what an XSL file looks like. And in the middle part where it says JScript, that is just some JScript that we've included that's popping calc. But obviously you could put any JScript in there that you want. And so the way we would abuse Wimic is by calling Wimic with any legitimate Wimic command. So in this case, process get is what we're using, but really it could be anything. Like you could query other OS information, and then we're doing /format. And then in the format flag, we're passing in the XSL file. And I will note, if you're using a file that's not in your current working directory, it does need to be in quotes. And that's tripped me up a few times. So just take note of that. And we will get to this next after the exercise number 4 that you guys are going to work on. But we can also insert basically arbitrary C# via the tools .NET to JScript or Gadget to JScript. But we'll cover that in the next slides. For now, let's work on exercise number 4. You'll need the calc.xsl file, and all you got to do is basically run that with this command. So once again, I will pause for 10 seconds, and then I'll pick up with the demo. All right, so let us see the demo for exercise number 4. So let me start this here, and we see that this is the calc.xsl file that we were referencing before, and there's JScript in there. And so we're going to basically just call Wimic with a normal command and reference that calc.xsl file. So we have there C Windows System32 WBEM Wimic.exe, process get, the format flag, and we're passing in calc.xsl. We run that, and pretty immediately we get the calc pops up. So pretty simple. And you will notice it says error, description, unspecified error. Like, don't worry about that. As long as it executes, it's all good. And so like that was a pretty simple demo, but again, it kind of goes to show you a proof of concept for what you can include in the XSL file. So I mentioned you could put arbitrary C# code into those files. And so let's talk about that. There are tools, specifically 2 tools. The first one was .NET to JScript that allowed you to basically convert arbitrary C# code into JScript. And so it's a pretty sweet tool. This revolutionized offensive security quite a bit. And it actually goes beyond just JScript. You could put into VBScript or even VBA. But it's pretty sweet. Like you can use .NET to JScript to basically serialize and then deserialize and execute arbitrary C# code. So you're not constrained to just using whatever's available in JScript. You can just code in C#. So that's kind of cool. But recently, and this is from Rastamouse's blog post, this is a screenshot of Covenant, the C2 framework. .NET to JScript has been starting to get caught on Windows machines. And I mean, kind of makes sense. Like there's an evolution of when tools are open source and eventually alerted on. And so .NET to JScript, I believe, came out in 2017. So there is an alternative to this called Gadget to JScript. This is the original GitHub repository. And the basic idea is it also will serialize your C# code and then deserialize it for you and then execute it. And the way it does so is just slightly different than .NET to JScript, and it's not necessarily getting caught. And there's some specifics on how how it's a little different. If you're curious, please just like Google search Rastamouse gadget to JScript, and he has a great blog post on it, kind of explaining some of the differences and why he likes gadget to JScript. Although to be fair, it was originally developed by this user on GitHub. But when we use gadget to JScript, we use Rastamouse's forked version. And the reason we do that is that it's just slightly easier to use. And so these are the steps when we want to use gadget to JScript. So we take a C# file. It needs to have a public class and a public method of the same name. And I think technically that would be called a constructor. And then you call the gadget to JScript binary. You pass in your code, any needed reference assemblies. You specify the output language, so in this case, JScript, and then the output file name. And that's it. Like then you can take that JScript and put it in any XSL file that you want, or you could put it in a COM scriptlet file if you remember that from the register server 32 explanation. And so this is an example on the left of the C# code. So again, the class name needs to be the same as the constructor name. So in this case, it's just the word same to really drive home that point, even though that's not a normal class name, but I guess why not? And here again, we're just starting calculator, and there you can see on the right running gadget to JScript, and it worked well. But on the other side, if you were to put like void into the name, so it's not a constructor anymore, I guess that would just be a method, like gadget to JScript is going to throw this error. So just to give you an example of like what to look for. After you compile, or rather serialize your C# code into JScript, I recommend testing it out to see if it runs. And you can do so with the utility wscript. So if you just call wscript and then whatever file.js you outputted to, it should execute that code. In this case, just popped calc, as you can see in the bottom right. And so after you have that JScript, all you have to do is add it to your XSL file, and you're good to go. When I say add it to the XSL file, I mean within the C data brackets from within that JScript tag or section. So that brings us to exercise number 5. This is the most involved. There's 3 files that are needed, technically 4, but really 3 you need to worry about. So gadget.cs will contain our C# source code. Calc.xsl, which we just used, we're going to use to replace the JScript. And then the gadget to JScript binary, which is a version I compiled from Rastamouse's forked version. So entire credit to Rastamouse and the original author. I just included it in the files so it'd be easier for you guys to use. And so you run gadget to JScript with that command that I showed you before. You take the outputted JScript file and throw that in the XSL template. And then you can call Wimic with like any legit command, but process get is enough to start. And then the format flag, you're passing in calc.xsl, which again is the file that you put your gadget to JScript in. So once again, I will wait 10 seconds for you guys to pause and give that a shot, and then we'll pick back up in a little bit and do a demo. All right, this is the demo for the gadget to JScript Wimic exercise. So here we have quite a few files. So you see gadget to JScript, and the ndesk.options.dll is needed for gadget to JScript to run, but you don't need to worry about that really. Our gadget.cs file is going to be passed into the gadget to JScript executable. We're saying it's of type JScript. The file is called out, but let's quickly take a peek at gadget.cs to see what we're dealing with. Again, we have a class of the name same and a constructor for that class, and we're passing in process.start calc so that we can just pop calc easily. So we'll run that through gadget.jscript. You can see a file called out.js was created. So we'll open that up in Notepad. So there is the serialized payload, as well as the needed functions to both deserialize it and execute it. Again, this is structurally similar to .NET to JScript, but less likely to get caught at the moment. We'll call wscript and pass in out.js to make sure it works, and sure enough, calc pops. So that means that JScript file will work if the JScript is run. We're going to open up our calc.xsl file, and we're going to place in and copy our JScript into that. So we removed the original, we added in the new gadget to JScript. We saved that, and then we're going to call WMIC again under the system32 WBEM directory. Do a process get, and then pass into the format flag calc.xsl. Again, that's our altered XSL file. And then once again, calc pops up. So hopefully that was kind of cool. I imagine many of you have heard of .NET to JScript, or maybe even Gadget to JScript. Maybe you didn't have an opportunity to use it before, and hopefully that was kind of cool to experiment with that, because that's something we use a lot for developing payloads. And here's an example. When I was running through this video, I originally was running this, trying to do the recording on a locked down, like a super locked down VM that had device guard running. And I ran Gadget to JScript and then realized, obviously, since that's not on the approved list, it won't run. And I got this, the system cannot execute the specified program, which was really annoying, but also is like it's ironic. I'm building this workshop on app whitelisting, and I just forgot that I can't run an arbitrary exe on a VM that's locked down by device guard. So anyway, I thought I would include that because that was kind of, I guess, funny. I don't know. It was annoying, but I laughed. So just like MS Build, I also want to note that you can remotely reference an XSL file. So same idea here. You can see an example. Also, if you're remotely hosting it, consider mod rewrite rules. So mod rewrite rules are related to Apache. It's a module in Apache, and it lets you get pretty specific about things. And one of the things you can configure is saying if a request isn't from a specific user agent, then deny it. And that's what we're doing here with these rules. And specifically, I'm saying if this is not from Microsoft WebDAV mini redirect, if it doesn't have that user agent in, or that string in the user agent, block it. And so this is just like a very naive way to block defenders from investigating a payload if they see that when they're auditing command line arguments. Because if they try to see that in like a browser, for example, they might not see, well, they're going to use a different user agent, but just something to consider, just something to think about. And in terms of what extensions will work, .xsl or no extension will work, whereas .txt, .xml, both of those do not work. So just something I was experimenting with, and in case you were curious, that is something to consider. Okay, this is the last bypass. Hopefully you guys have learned something so far and have enjoyed it. Big caveat to this last bit of research. This is like brand new for me, and I have not used this on an assessment yet, but I have all intentions to do so, and I'll explain why. But I just wanted to share that up front in case it doesn't work exactly as expected. But I wanted to include it because like whenever I'm doing a talk or a workshop, I love to include something that's like at least brand new to me, and entirely new from any prior related presentation, just because the likelihood of somebody watching this and having some experience with MS Build or WMIC or Register Server 32 is decently high, but I can almost guarantee you haven't experimented with this. But if you have, please tweet at me, let me know. That'd be awesome. I'd love to hear that and love to hear how it's working for you. So the reason I started thinking about this was this Red Canary blog post back in January, and it was discussing how red teams could use the F# or C# scripting interfaces, which I had never heard of, to bypass app whitelisting or just generally to execute code. And I'll explain what these fsi.exe and csi.exe are in a second. Curiously enough, I was doing, I don't even know how I got here. I was looking something up for this presentation. I saw Bohops recently wrote about literally a week ago. So my presentation was already in the works, but I didn't know he was also looking into this too. And this happens a lot in the InfoSec community, and it's awesome. He was looking into how fsi.exe can be used to bypass WDAC. And that's exactly what I was working on too. And so kudos to him to work on it as well. And he was referencing some work that was done in 2017 on this that I feel probably got way overlooked. So this isn't new per se, but I haven't seen anybody really use this. And that's kind of why I thought I'd bring it up for you guys to look at. And so FSI or CSI, these executables, this is kind of what it looks like when you kick it off. It's like an interactive scripting console. It looks a little funny and different. These interactive commands have a hash, a letter, and then it ends with 2 semicolons. So that's kind of weird, but that's just the way it works. And this is Imagine it's like PowerShell, like the interactive console, or Python or Perl or PHP, like any of these that have this interactive like scripting interface. So does F Sharp and C Sharp. And I had no idea this even existed. And that's kind of cool. And the idea here is CSI is, as you could imagine, for C Sharp, FSI is for F Sharp, and you can create scripts in both those languages. And then you can run them using these tools either interactively, like you could just like go bit by bit, or you could just run a script. And that's super interesting. So like, it's kind of like as if Python was installed on a target machine. You can just run a Python script. Like that's super easy to do, but Python's usually not installed on Windows machines. And if it is, it's usually a dev's machine, if at all. And so there's two ways to use this. The first is if you land on a machine or even your own that has Visual Studio installed, under the, like you can see the path in that image, but basically under this F Sharp folder, you'll see FSI, fsi.exe, and there are a whole bunch of like dependencies in there, but really only 4 of them are necessary. And I'll show that on the next page. If you get on a box that doesn't have Visual Studio installed or even your own, you can still run FSI, but you need these 4 additional DLLs. Like that's the bare minimum that you need. And so you could imagine getting on a host and uploading these 5 files. These are Microsoft Sign files, like totally legitimate files. But if Visual Studio is not installed and you have a really like savvy defender, they would look in and be like, well, why is like somebody without Visual Studio using these files? Like that's kind of weird. Like, yeah, that might stick out, and maybe, and hopefully that's how defenders look to this. But like, it's super easy to upload a file on a machine that you have admin access to, and like you could upload these and then run a bypass using FSI, using an F Sharp script to get a beacon or whatever, like interpreter session on the remote machine. So really there's 2 options. Either Visual Studio is already installed, or you copy paste these DLLs to the target machine. And so in this presentation, I decided to go with FSI, primarily because CSI, I think, is relatively known. I think defenders would have an eye out for it. I don't think the same is true for FSI. Granted, I think they're functionally equivalent, but more people code in C Sharp than F Sharp because F Sharp's a huge pain. I do know some people will disagree and like they really like F Sharp, but like coming from C Sharp and trying to learn F Sharp, it's just like slightly off. I'm like, why is the syntax like this? Like, why are you doing this? It's just like slightly different. It's really annoying. But so I decided to go with F Sharp despite the frustrations with scripting, just to show you something a little different. And here's an example. So in the background, there's a Notepad F Sharp scripting file that's just calling calc to start. And it's as simple as calling the FSI binary and passing in the path to the F Sharp script file. And their calc popped up, pretty simple. I will note that I tried this on a device guarded machine, and this is just kind of a good example to show you how device guard blocks DLLs, but I had the F Sharp code, actually the C Sharp code on the left, that I compiled into a DLL, and then I tried to interactively load that DLL. You can see here it says #r space calc.dll. That's like functionally the same code that you guys just created a DLL with before with Gadget to JScript. And when I tried to reference that DLL or load it, it was blocked by device guard. So that's not necessarily a limitation of this, although I guess you could consider it. I more included this so you guys could see like what device guard blocking a DLL looks like. But when I was trying to come up with a proof of concept for you guys to demo this, I stumbled upon, I believe, Vincent Yu's GitHub repository from a couple years ago, and he had this like proof of concept F Sharp shellcode script, which I was like so pleased to find because then I didn't have to code one from scratch. It's like very basic shellcode injection, but it's good for proof of concept, and it didn't involve me getting really frustrated writing an F Sharp script. So that said, we used this one, and full credit to him for creating that. One thing I will note is shellcode in F Sharp is a little wonky. So if it's a byte, which is the bottom row there, you have to add UY after the hex. And I can show you what that looks like on the next screen, but I just wanted to call that out. So this is Vincent's F Sharp shellcode proof of concept with shellcode that I added in there. So that shellcode I generated with MSF Venom just to pop calc. And if you look into it on the right-hand side, you see like hex 89 is the starting byte, and then it's like UI at the end, and there's UIs after all of it, and then semicolons. And like It's a pain, but like that's just how it works. It'd be easy to script that if you wanted to dynamically build these, but like that's just the setup. And then on the left-hand side, you can see there's some library or reference assemblies referenced. We are defining a few functions for process injection, like virtual alloc, create thread, and wait for single object. Bit outside of the scope to like go into process injection in this workshop, but that's what's going to be injecting our shellcode into memory. And then sure enough, I ran it and calc popped. And I was like super jazzed because this is pretty awesome. I'm personally going to be spending more time writing additional F# scripts that can do more fancy process injection, like in terms of like remote process injection as an example. But this is a great proof of concept, and it shows that if you upload these 5 FSI related files, 4 DLLs and fsi.exe, and then you pass in an F# script file, that you can do some process injection. So this is the last exercise. Please go ahead and grab the calc.fsx file. If you have Visual Studio already on your Windows machine or VM, just do a Explorer search for fsi.exe and then get into that folder and you can operate from there. If you don't have it, this Dropbox link will be available through the end of the weekend, where we have those files hosted for you. But again, these are Microsoft files, so we're not like going to be publicly like giving them out to anyone. This is really just as a proof of concept for during the workshop. So please delete them after you use them and purchase Visual Studio. But that said, we wanted to provide those so you could use it. And then all you need to do is call it fsi.exe and then calc.fsx to execute it. So once again, I'll wait 10 seconds and then continue on with the demo. All right, so this is a demo for the last exercise, exercise number 6, and let's see it here. So this is the F# scripting file. You can see some reference assemblies. We're calling out a few functions that we need for process injection. So again, virtual alloc, create thread, and wait for single object. We have our shellcode, and I have a couple comments that explain how it was generated and how you could do the same thing there. So with this wonky UI business, again, that's just peculiar to F#. And then down below, we are allocating memory. We are copying our shellcode to that memory. We are creating a thread and waiting for it so the process doesn't exit before this thread is done. You can see here we have the 4 DLLs plus fsi.exe. That's all you need for this to work. You can then call fsi.exe and pass in a path to that fsx file, which is located there. We'll run it. It is injecting the calculator shellcode. And sure enough, in a second, hopefully, there it is, calc popped there. And again, that's a cool example because you could easily just like sub in some interpreter shellcode or shellcode for a beacon or whatever you need to. So that was FSI. I think that's super cool. Hopefully that was brand new to you. Again, credit to those that did research in prior years, but this is really something that I haven't seen used much or talked about much. So hopefully this gets the conversation going a little bit more and you guys test it out and try using it because I think this is going to be an area where defenders won't have much visibility. So just a few slides on detection. I'm not a defender, so I don't feel qualified to talk much about it, but I do want to highlight just a few things. You might be thinking if you're on the defensive side, like, wow, we spent all this time implementing an app whitelisting solution and now people can just bypass it. Like what? Like why spend the time, all that effort, not only getting buy-in from management to deploy it, but actually deploying it and building those rule sets? Well, first off, I will say EDR is getting pretty good at detecting some of these bypasses, but more importantly, there are ways to establish basically blacklists on the whitelist. So it's kind of counterintuitive, but there are ways to create deny policies. And this is from Manifestation, Matt Graber, so you can find this on his GitHub. He periodically updates this, and basically this has a list of known app whitelisting bypasses. And the way this becomes a blacklist is it says on the far right in one of those boxes, you can see it says minimum file version. And that's 655.35 dot the same 4 times. And that is the max file version that any file could be. And basically that's saying is like, yeah, MS Build's fine to run as long as the file version is at least what you see, that number there, that super long number. And the reality is MS Build is nowhere near there. It'll never be there. And this is effectively a way to block the execution of MS Build on a machine. And so that's pretty cool. So this is a way, like if you're a defender, you could, assuming it fits your environment and the needs of your network and hosts, you could just plug in a whole bunch of these app whitelisting bypass binaries into a rule set like this and then essentially block them. I highlight the second box below because CSI is on there, and it's been on there for a long time, since I think 2016. And again, that's referencing work by Subti, but FSI is not. And that kind of like was the impetus for me sharing FSI with you and doing more FSI.exe research or F# research. So I just wanted to share that. But definitely check out those rules, especially if you're on the defensive side. That is one way to do it. And also, if you're on the offensive security side, it's good to know this to share that with your clients. And with that, that is the end of the workshop. I hope you guys enjoyed. You can find me on GitHub and Twitter at Joe Leon Jr. Again, I work with 40 North Security. We do a lot of different training and topics like this, and we also publish a lot of open source tools. So feel free to check out our GitHub repository as well. And if you have any questions, I hopefully will have been available on Discord this whole time answering questions. But if you have any additional questions, always feel free to reach out. Again, Discord would be fine if you find me on there, or again, Twitter is fine to tweet at me, or GitHub if, I don't know how you'd contact me, but whatever it may be. I'm always happy to answer questions. I love contributing to the community and helping out anyone that I can. And with that, thank you so much for listening. I know this was part of your Saturday, so hopefully you enjoyed that. And if you have any questions at all, again, please feel free to contact me. Thank you so much. Have a nice day.